Hi, I'm Coach Cowland, and in this presentation we're going to continue looking at projectile motion. So first of all, what happens when you throw a ball to someone? How do the components of its velocity change? Think about your answers to these questions before moving on. Just as a recap, we're going to look at vectors again. Remember that initial velocity, acceleration, final velocity, and displacement all have x and y components that need to be kept separate. Because time isn't a vector, we can use it interchangeably between x and y dimensions. Because gravity is the only acceleration that affects projectile motion, the vertical velocity is going to change. Because gravity has no horizontal component, the horizontal velocity will be the same. What do you notice about the path of this projectile? This projectile is both parabolic and symmetrical. The fact that it's symmetrical is extremely useful to us to help predict its motion. If we look at the components of velocity throughout the projectile motion, we notice that the horizontal component remains the same. We also notice that the vertical component of velocity decreases until it reaches zero and then becomes negative on the way down. The point at which the vertical velocity is equal to zero is the time taken for the object to reach its highest point. This is half the time taken for the object to reach the height at which it was launched. This is an important piece of information and one that we will use continually in this section. Let's try an example. A cannonball is launched at 8 meters per second at an angle of 20 degrees above the horizontal. What is the maximum height the cannonball reaches? First, let's identify the information. This time, instead of listing the variables first, I'm going to do the diagram first. The diagram on the left gives me my vertical and horizontal component of the initial velocity. I also know that at its maximum height, its final velocity in the y is going to equal 0. As you can see, I have a large amount of data to begin with. It's important to separate vertical and horizontal data. Because I know my final velocity in the y is going to equal 0, I can find the time taken to reach that point. Now I can substitute time into s is equal to ut plus 1/2 at squared. This will give me a vertical component of displacement of 0.38 meters. Okay, so that's the end of the presentation. So what I need you to do is go back through it, make notes on everything that we've covered, complete the examples, check that you understand them, write down any questions that you have, things that you would like to go over in class. I'd like you to think of at least 2, and be prepared to continue on working on this in class, and I will see you then. Goodbye.